Okay, so we want to do this question. We started doing problems like this right before the spring break, and then, of course, that was before all of the bad things that happened. So this is the surface is given by the graph of an equation, z is equal to x squared y squared plus xy squared. And there's a number of ways to do this. I'm going to do it one way. I'm going to first make this, instead of writing it as the graph of a function, I'm going to write it as a surface level, or a level surface. So I'm going to define a new function, f of x, y, z equals x squared, y squared plus x, y squared minus z, and this is equal to 0. Okay, and we want to find the equation of the tangent plane. So we want the plane tangent to this surface at that point. So remember, the two pieces of data that we need are a point on the plane and the gradient vector for the plane. So let's find the point on the plane first. So we know that x is 1, y is 2. We'll use this formula to figure out what z should be. So if x and y are 2, you just, wherever you see an x, you put a 1. Wherever you see a y, you put a 2. That means that this is going to be 8. And the gradient of f, okay, so the x derivative is 2x y squared plus y squared. And the y derivative is 2x squared y plus 2xy. And then the z derivative is just 1, negative 1. Okay. Sorry, this last one is a minus 1. So the gradient of f evaluated at the point 1, 2, 8. Well, wherever I see an x, I'm going to put a 1. Wherever I see a 2, wherever I see a y, I'm going to put a 2. And if z appeared anywhere, I would put an 8. But it doesn't. Okay, so that means this first component is going to be 2 plus 4, that's 8, plus 4, that's 12. The second component, this is 2 times 2, that's 4. That right there is 4, so this is 8. And then minus 1 is the last component. Okay, so the equation for the plane, this is the normal vector, this is the point on the plane. So remember, we did this in the beginning of class. The normal equation for the plane is going to be 12 times x minus 1 plus 8 times y minus 2 minus z minus 8. And we set this equal to 0. This is the equation for the plane, but we are being asked for the z-intercept. What that means is we set x and y equal to 0 and see what that means z has to be. So if x and y are equal to 0, this becomes minus 12 minus 16 plus 8 is equal to 0. Is equal to z. If I just move the z over here, that's what I did. Okay, so minus 16 plus 8, that's minus 8. Minus 8 plus minus 12 is minus 20. So the answer here is minus 20. Okay, so to recap, we said we wanted to get a tangent plane. We need two pieces of data for that. We need a point on the plane, and we need the normal vector. The normal vector, when you write the normal vector of a level surface, if it's a level surface, in other words, f of x, y, z is equal to 0. If it's a level surface, the normal vector is just the three-dimensional gradient of that function. And this is the three-dimensional gradient. We plugged in 1, 2, 8, and that was the normal vector. And then we just did the things that we've done in class so far.